All right. Good morning, everybody. How are we doing today?
Just great. I'm doing pretty good.
Great, great. So today we're going to review variables. We're going to talk again about declaring, assigning, and reassigning variables. We're going to talk about compact variable declaration. A couple more things about printf. And we're going to talk about assignment 2, which is due Sunday night at 11:59 p.m. Central Time, and we're going to have another in-class assignment as usual. So, questions or concerns before we get started? All right. So, variables. I'm just going to go through and write another program just talking about variables just like we did before. Just remember, I'm going to use the Vim editor. You could just replace Vim with Nano, or learn how to use Vim before using it.
So like, is on the screen like the same stuff? It's just like a different editor area?
Yeah, so Vim's just a different editor. The text is the same, it just...
So it does everything like the same, it just looks different?
It does everything exactly different. It does everything differently, basically. So normally you could use the arrow keys to navigate, or whatever. So in Vim you'd use JKL, or I'll make a couple lines here. And you use like J and K is up and down, H is left, and L is right. And then Vim is all about different modes. Like if I put it in, by default it's in command mode, and whatever I type on the keyboard is interpreted as a command. So if I want to delete, just for example, if I want to delete a line, I can press DD and it'll delete the line. And you learn, there's a bunch of different commands, and it takes a long time to learn, and it's not exactly easy to do.
Are they all like needed?
Needed.
Like, do you use all of them?
I mean, I use the core ones that speed up what I'm doing, but but yeah, don't waste your time with it if you don't care.
What's an example of something you wouldn't use? Just like,
What do you mean wouldn't use?
like very often a command that they have is not really useful.
See, I don't know enough of the commands to say that.
Yeah, okay.
But I mean, just talking about, like, let's say I have a line of text like this, and I'm in the center of it. I can press $sign to go to the end, or caret to go to the beginning immediately.
Oh, that's nice.
Or I can push O to start typing in the next line. I can delete that again with DD.
Saves. Wow.
Or I can push capital O to insert a line before and start typing immediately on that line.
That's nice.
So it's an interesting editor. I mean, by all means, play around with it sometime if you have free time, but it's not required for this class, and you can pretty much accomplish everything that I accomplish in it. In Nano. Oh God.
It's so much easier.
Hey, wait.
Maybe.
Is there like an application like Dreamweaver that's for this code too? That'd be pretty.
Yeah, there's all sorts of other applications you can use to develop this. It's just a common environment that works pretty well.
Codebox. Okay.
So one of the main things we do in this class is Linux. It's one of the main objectives in this class is Linux fundamentals, and just getting you into a Linux system and kind of experiencing how that system operates versus a traditional GUI-based environment.
So do we move to a different system later on?
Basically, for all the C programming you do while you're in school here, you'd be in a command line environment, at least as recommended by the instructors. So, back to where we were going.
That was only 4 minutes.
Oh, I see how it's going to be. You're going to try and derail this class. Okay. So, talking about our main data types, we have integer, which is shortened to int. We have floating point, which is shortened to float. And we have character, which can be shortened to char. So let's say I want to declare an integer and call it a. And remember, we can call a variable anything we want to. I can call it a, I can call it my thingy, I can call it my underscore thingy, I can call it my thingy number 1. Yeah, I can call it whatever I want to. So let's just do a for now and set it equal to 10. So let's go ahead and output that integer, %i/n for the new line, and then a. So we can see it outputs 10. So going back into that program, we can also manipulate those variables throughout the program. So after that, after we output it as 10, we can say A equals 11. And then we can go ahead and output it again. So now we can see we have 10 and 11, but we only have one variable. And we can continue to use that variable as much as we want. We can assign it different values throughout our program. So typically what we do is, oh, okay, so here's another one. We can also declare a variable without anything in it. And then we can go on and use it later. We don't necessarily have to give that variable a value when we first declare it. It's really up to you if you want to keep your variable separated from your numbers and where you're using them. So one thing that we can also do is we can declare lists of variables of the same type. So we can do A, B, C. So those are all integers, and those are all available for us to use now. I think we can do this, I don't remember for sure. We can also set those variables equal to things right as we're declaring them. So you can see that those three variables that we declared in that line are all available to us. So basically when we're declaring, that's what I would consider a compact variable declaration. And so you put the data type as the first line, or the first word, and then one variable. And this part is optional here. Again, you don't have to do that right there. You can do it anywhere you want to. You could remove all of this and then declare it later. And you can declare as many variables as you want. Just comma separate them, and they're all the same value. And you can do that again if you want more variables. And you can continue doing that on. You can put both of those on the same line. It doesn't matter at all. Just make sure they're separated by commas. And then again, we can go and say A equals 1, B equals 2, C equals 3.
I have a question. Is there a limit to how long the line can be?
Traditionally, when you're writing a program, it's depends on who you ask. If you ask me, I say as long as it fits on the screen, you're good. A lot of people will say 80 characters, so counting from left to right, you don't want to go more than 80 characters. And that's traditionally seen as the good standard.
So how do you copy and paste them?
So on Nano, or it's so you see down here there's Control K for cut and Control U for uncut. So as it happens, you can cut and then you can uncut twice. You can uncut as many times as you want to. Yeah, so it'll always cut, but it just stores what you cut out in memory. So you can continue to uncut. Oh, yeah, something like that. And again, I feel like it's Control. I don't remember what it is for the help for, yeah, it's G. So you can read like the Nano help by pressing Control G and reading about different things if you want to learn more of the fundamentals of the Nano editor. Let's see here. So just remember that if we want to declare multiple variables on one line, we can do that. But if we want to declare a different type, like float, we have to declare that on a different line too. And we can go ahead and we can't have variables with the same name either. So I named that A, and I also have an integer named A. So if I close this and compile it, it'll say a previous declaration of A was here, and it'll show you where that variable was declared before. So you need unique names for all of your variables. So if I rename that to AB, then it'll compile just fine because it has a unique name. So we did compact variable declaration. So we're going to talk a little bit more about printf formatting. So one of the things that you might have noticed is that when you're printing out floating point numbers, you're usually given 6 decimal places, and that's not something we always want to do. So we can instruct printf to manipulate our floating point numbers slightly differently. So we're going to talk about just printf formatting of floating point numbers. So by default, when we do %f, it'll output the float with 6 digits. But if between the % and the f we do a period and then a number, it'll output that many floating point digits. So let's say we do 0.5, it'll output it with 5 decimal places, and 0.2, it'll output it with 2 decimal places. So I'm just going to go demonstrate that quick. Equals 1.111. So you can see that it outputs with 6 decimal places, even though we only defined it with 3 decimal places. We can go back and we can say 0.6, which by default will still output with 6 decimal places. So we can see 6 decimal places. We're just specifying exactly how many decimal places we want to print out. And we can drop that down to 2. And we can see that that floating point number now outputs with 2 decimal places. We can even go all the way down to 0, and we can say we want 0 decimal places, so it'll print out nothing after the decimal place, even if we've declared something to be there. So we can manipulate how we can output floating point numbers and how they're displayed to the user. Now, we can also add padding to the left side of the number. So we can say %10f to output a total of 10 characters. Now, this is kind of misleading because it says 10 characters, so that includes everything to the right of the decimal place itself, and all of the numbers that are that you already declared. It depends on how you are outputting your number. So with 10, we have our 6 decimal places to the right. By default, always, we have our periods, that makes 7. Then we have 8, 9, 10, up to the 100th, place, yeah. So if we have a number shorter than 10 characters, when it's outputted fully with those 6 to the right, that decimal place, and however many numbers we have, then it'll add spaces to the left of the number. So looking at 1.111, let's say we do 10. We can see that we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So, if we want our numbers to line up or we want them outputted in a certain format, let's say we had another floating point number. we can see that the reason we want to do this is so we can have our numbers line up. We have the decimal places in the same spot, so it just makes the numbers a lot more readable. We can also zero pad numbers. So looking at, it's exactly the same. It's just you specify what character you want your numbers to be padded with before you say how long you want them to be padded with. So by default, it'll pad it with spaces, but it can also be padded with zeros, or I believe any other character. I'm not for sure. I'll have to test that. But so just going back in our format identifier, press putting 0 instead of 1, or instead of nothing. We can see that instead of having spaces, there are zeros there. And I believe you can replace that with any character. I don't know for sure, though. So that's a special character, but let's say I want to do... Yeah, I think you can only do it with zeros, but... So, that leads us to the final component of saying we can combine those two things. We can say how many decimal places we want by saying point our number of decimal places, and we can also say we want that to be padded out to 10 digits. And we can also say that we want our padding to be zeros instead of spaces. So going back to this, we can say we want to output 2 decimal places, but we want to pad it out 10 digits. So we can see we still have 10 digits. It's just since we have less digits on the right, we have more padding on the left. So starting from left to right, we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So going back, we can go and say we want it to be padded with zeros. We can change that to be 0. Compile it again, run it. And we can see that those spaces have been replaced with zeros. Now, again, we can change how many digits we want it padded out to. So let's say we want it padded to 6. We can change that 10 to a 6. And we can see, again, we have 1, 2, 3, 4, 5, 6. Again, including the digits, or the decimals to the right, including the digits to the left, and the period. So that's really a basic overview of formatting floating point numbers, just to display them how you wish to. So, assignment 2, again, is due Sunday at 11:59 p.m. In order to view the requirements, go head to the content section in D2L. It's under week 2, assignment 2. So I'm just going to read through it really quick. This assignment will be submitted on dev.dsunix.net. If you want to develop it somewhere else, that's fine. Just make sure it compiles and runs on dev. It should perform the following items. Declare and assign 3 integers, 3 floating point numbers, and 3 characters. Output 1 variable of each type on a line 3 times. Output 3 variables of 1 type on a line 3 times. Assign all the variables new values and output them again as described above. So, let's say A is my first character, B is my second character, and C is my third character. So when you're outputting those, when you're writing your printf statements, you want to make sure that you have declared a variable and then you're outputting that value. You also want to make sure that you're using the same variable for outputting A as you're outputting A down here. And then, so in this space right here, in your code at least, that's where you'd reassign all of your variables. So you've declared all your variables up at the top of your program and you've assigned them values. And then after you've outputted the variables the first time, you go back, you reassign the values, and you essentially run the same printf commands as you ran before. So your variable name should be unique. The values you assign your variable should be unique. And then floating point numbers should be outputted with a precision of 2 decimals. So what we were talking about today. So you could run /dist/assignment2 to see a program which provides sample output. So just like dist assignment2. And that's the program that I've written that provides the sample output.
And when is this due?
So this is due Sunday at 11:59 p.m.
Okay.
as shown here.
So we just need to get it to output like those exact same.
Yeah, and you need to, your values that you output here need to be derived from variables. So you can't literally print, so I could do this. Let's do this. I could write puts a 10 11.1. And it looks right. But if you do that, I'm probably going to give you negative points. So
So we do like. So we do like printf.
yeah, you need to do printf. You need to, again, declare the variables like we did.
Like what we did like at the beginning. So
Yeah, so take your variables here. You can either, you can declare them without assigning them a value, or you can assign them a value later. And then you write a printf, you write a bunch of, like, you're probably going to have 6 printf statements for, like, that should be real, you don't necessarily have to do this, but this is how it probably should be done.
each one of those lines.
Yeah, this should be a printf, this should be a printf statement here. This one should be a printf statement, printf, 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 printf. Printf, 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 printf. So you should have a total of 12 printf statements by the time you're done.
Okay.
So that's assignment 2. I'd recommend that you get started on it as soon as possible and contact me with questions before Friday. If you want to ask any questions on Friday, by all means do so. So we're just going to dive into format specifiers a little more with our in-class assignment today. So we are going to write a C program which performs the following function. We're going to declare and assign a floating point number. We're going to output it with 3 decimal places and 0 padded to 7 characters. And then we're going to reassign the variable to a different value and output it with the same specification. So 0 padded to 7 characters with 3 decimal places. And then we're going to submit it to day 4 in class. So any questions about what we talked about today so far?